So another method to solve systems of linear equations in two variables would be the substitution method. And we're going to look at the same examples that we did previously, but we're going to learn a new method. We're not going to be graphing these at all. And so to outline the method of substitution, we're just going to lead by example and write some things down. So if I'm asked to solve this system by substitution, I have 2x plus y is 4, x plus y is 2. What I need to do, so my first step is I need to choose an equation and isolate a variable. And in theory, it does not matter which. But in practice, you're going to discover that sometimes it's easier to solve one equation for a particular variable than the other. It's usually, in order to avoid fractions as much as possible, just because it's more work to work with them. And so if you can identify something, without doing the work, if I look at the first equation, if I want to solve for x, I have to subtract y from both sides and then divide both sides by 2. And I can see that I'm going to have a negative 1/2 in front of my y variable. So solving the first equation for x is going to be a little bit more work. First, it's more steps. Second, I know I'm going to deal with a fraction in there with the slope in front of, well, the number in front of y. The coefficient of y, that's the word I was looking for. Now, if I were to solve the first equation for y, or I look at the second equation and I want to solve it for x or y, it's just one step. I'm going to subtract and I'm done. Let's solve the second equation for x, just because. So, and again, it doesn't really matter, but you can pick and choose, and there's no right way to do it. It's just the way that's more comfortable for you, and practice is going to tell you. So if I solve the first equation, so x plus y equals 2. If I solve it for x, I have to subtract y from both sides. X is 2 minus x. I'm sorry, 2 minus y. That wasn't making any sense. Now that's better. All right, so x is 2 minus y. And my second step, so we need to substitute in the other equation. So since this is x is 2 minus y, I'm going to substitute that x in that other equation, and we have to use the other equation. We can't do the same thing, otherwise it's not going to work. So I used the second equation, solved it for x, and I'm going to get that expression that I got for x and plug it into the other equation. So that's going to be 2 times 2 minus y plus y is 4. All right, now we can solve this. And actually, we could put that into the, so we can plug it in and then solve. 4 minus 2y plus y is 4. So I've got to get rid of the parentheses first. Now I combine my like terms. 4 minus y equals 4. And if I solve for y, I subtract 4 from both sides, and you get a negative y is 0. And in this case, it's not going to make a difference because the sign of 0 doesn't change. But make sure you pay attention to your negatives. That doesn't disappear. If I divide both sides by negative 1, I get y is 0. Okay, so we know that y is 0. We're going to plug that value in that we got into either equation. And it doesn't matter which one at this point. You can use either equation. we're going to get x equals 2. And if you recall, we have a point of y of 0 and x of 2. So 2 comma 0 is the solution, which was at x-intercept, and that's what we got in the previous video, and this is the solution. You can also plug it back in to check. Takes just a couple seconds. Plug it back in the original system and see if it works. In our second example, we're told to solve this by substitution. And hey, there's already something by itself. So I'm not going to do any extra work if I don't have to. So if I'm told to solve this by substitution and they already isolated one of the variables, I'm going to take this 2x minus 2. I'm going to plug it into that equation. Okay. So I'm going to make that substitution. And I'm going to clean it up. Okay, so we get 2x plus negative 2 minus 2 is 4. Oh, oops, that's a 2x. And you have to be careful. 2x and negative 2x cancels out, and I get a negative 2 is 4. Uh-oh. That doesn't make any sense. Can negative 2 ever be 4? No, it can't. Let's go back to make sure we didn't make any mistakes. Combine my like terms after the substitution. I didn't lose any signs. Everything looks good. So I get this gibberish statement. Okay, and this can happen if you turn that crank and try to solve for the variable, and you get some statement like negative 2 is 4, which we know is not true. This is indicative of no solution, which was, if you recall from the previous video, these were parallel lines and they never meet, so they were not to have no solution. And so, yeah, we might have a little perceptual discontinuity happening there, but that is what happens. Third example, and if you recall, this is the one where we had the same line. So we're going to learn what that looks like in this situation. All right, so again, we're asked to solve by substitution. So I'm going to look at that first equation just because it doesn't really matter. I'm going to solve that for y. And in this case, either way, we're dealing with one step to solve for the variable, so it's not bad. I just chose the first equation because now I'm going to plug this in to the other. I'm going to plug that negative 3x into the other equation for y. So 2 times negative 3x is negative 6x. I'm going to solve. I'm going to get negative 6x is equal to negative 6x. And we can actually stop right here because something is equal to itself. And if I add 6x to both sides, I'm going to get 0, 0. If I divide everything by negative 6, I'm going to get x equals x. As long as I'm consistent with what I'm doing, I'm going to get the same thing on both sides. And this is always true, which means infinite solution. And Web assign, that means we write it in that form, where we write x comma mx plus b. And we're going to look at the same 3 examples in elimination in the next video.